thanks for the introduction, and thanks all the speakers before me. It was really great to understand the different perspectives of, and that's what makes blockchain really beautiful, because there are so many different perspectives from legal angle, accounting angle, from each angle there's something in this. And to add to the point, like 1.2 billion or what he mentioned, if any one of you is like relatively new to blockchain space, the dollar value is a big distraction. It's just a token. It doesn't mean anything. It's a paper value. So try to understand as much as the technology and the ideology and these aspects, and people like Mohammed are bringing some really good products, and especially I consider myself really fortunate to be in Toronto, which is becoming like a big global hub for blockchain. The ecosystem is amazing. We have people from regulatory, every person is over here. And so I'll speak a little bit about smart contracts. But just before this, I'd like to introduce myself. So I read the Bitcoin white paper like anybody else. I thought first it was a scam. But the more I read into it, I started attending a few seminars, and I got really interested in it. I did a few certifications, then became a blockchain educator myself. I was working for Scotiabank as a blockchain consultant, and I just moved to Ucash. So I'm relatively new to the Ucash team. And at Ucash, we are solving the problem of first and last mile, which is everyone has these cryptocurrencies, but you cannot convert it to fiat, which is our Canadian dollar or the local currency. And that is the biggest problem. What is the point of having all these tokens if you cannot easily convert it to the different currencies, like your local currency? So at Ucash, we are partnering with money supply businesses, like your payday loans, Western Unions. They follow all the KML, the regulatory laws, KYC and AML, and and not everyone is technologically savvy. So any person can go to these stores, talk with a teller, and convert your crypto to cash. But the biggest use case and the problem that Ucash is solving is we are bringing financial inclusion to like the whole unbanked population of the world. So when I'm saying countries like Papua New Guinea, Vietnam, Indonesia, we went there, the team also talked with the central bankers, and we have explained how blockchain technology can actually help and bring financial inclusion in these areas. So now I'll speak smart contracts like generic way, not exactly what's being done at Ucash, but what smart contracts are. And before that, I'd like to give a brief history of contracts. So contracts have existed as long as since humanity started to transact items. So first was barter. Barter system was kind of like a contract. The two people involved just decided, I'll give you 1 kg wheat, you give me 1 kg rice. And that is very important because governments around the world are saying Bitcoin or like these digital currencies is a barter currency. It is not a legal tender. So we are going back to where we started. And that is why the history is really important. And like as I mentioned earlier, if in this space, it is really important to understand why this whole blockchain and decentralization, this philosophy came into place. What was the problem in the existing system and what it is trying to solve. Technologically, we are still probably a few years, there are still a few more years to actually achieve the potential, but definitely there is potential. And then contracts were like wired in the brain. So when I'm saying wired in the brain, in a small community, everyone knew each other, like how much land assets one owes. It was very common all over the world in small communities, in villages. Each person knew assets of each other person. So it was kind of a ledger which was maintained by the whole community. And that worked perfectly well in a small community or in a small village. And then there were social contracts. And even today there are social contracts. Inheritance is kind of a social contract. We are surrounded by contracts all our life. Even like after war, like a serious thing like war, countries divided and decisions are made based on the contract on who gets to rule what part. And this is happening even today. But then tomorrow some another political leader comes in, they just tear away the contract and even claim that the previous contract never existed. And all of this, and we may think we are in Canada, it doesn't affect us, but there are a lot of examples in Western countries as well where this has taken place. And even like especially the whole financial collapse is not following the financial contracts that were laid by the government, not following the rules. So then slowly from this barter system, as villages started to expand, there were more formal laws, like we became more cultured from the tribal mentality. And then there was paper-based contracts came into place. And there was more penalties, like formal laws came into place on laws as in all these rules on what happens on a particular event and what is the trigger and what should be the punishment. But this gave rise to a lot of different parties. So earlier it was very easy, just two people were interacting, it was easy to keep that, maintain that contract. But as more and the contracts also became more complex, there were more parties that were involved. So you had needed someone to do the trust, someone to hold your funds till that contract is not fulfilled. And this also gave rise to kind of corruption practices. And then finally in the 90s, when the dot-com boom, internet boom, and the entire technological innovations happened, we had a lot of electronic contract management systems, and every enterprise uses them on a daily basis. Like, you don't really need smart contracts. What is achieved by smart contracts, we have in our organization, there are a lot of electronic contract management systems which are taking care of this. But then what are the problems in the current electronic contracts? Like when I say electronic contracts, is non-smart contracts which we are using on a daily basis. So the biggest problem is now we say the world is flat. It is truly a global world. But then laws, rules are different in every region. When I came to Canada, I was working for NISA, and the laws for Quebec and non-Quebec states is totally different. So we had actually completely two different IT systems for Quebec, non-Quebec. But then it is actually a pain for the company and it's a big expense. So just think about this within Canada. In other countries like India, it's much more diverse. And now think about the whole world. So the complexity of these contracts, because of globalization, it's becoming very difficult to really automate them. Then there are too many middlemen. As I mentioned, there is banks, then there are escrow, someone is doing the escrow, there are lawyers who are bringing the trust for a contract. Again, all the parties have to be in agreement, and even if one party can attempt or tries to do some malpractices, then how to deal with it is a problem. And then this is like trust issue is really very common in the current systems. Then there is no guarantee of the contract conditions and the penalty being enforced. So this enforcement is also very critical, because right now, yes, the software-based contracts are taking care of everything, but there is no guarantee that the penalty is being enforced. So this is, again, it's time-consuming. There are tremendous overheads involved, and it is like there are chances of manipulation. Many times it is unintentional. Like when I say unintentional, it is like a clerical mistake in the database or a code. But this has a big impact on all of us. And still, like when I was reading about blockchain 2-3 years back, I was not really convinced. Like this is like we really need smart contracts. Why we need smart contracts? And then I read about, so this is Ray Dillinger. He was the first person, non-anonymous person, to review Bitcoin code. So he was literally the first guy whom Satoshi sent his code for review, and they come from completely different school of thought. So this school of thought is really important because those ideologies have gone in the design of blockchains and smart contracts. So because the developers of blockchain and smart contracts, they have this ideology, it has been programmed that way. So it is very important to understand that ideology. And this is what he meant is, trust is an epithet, in fact it's almost an obscenity. Trusted means something or someone has the power to break your security by acting in bad faith. Generally we have this mentality since we were kids, we are told like banks or anything you trust, you give them your data. When we are kids, we are told if there's a trustworthy person giving you chocolate, accept it. If it's not, do not accept it. So it's brainwired like any person you trust, you give away your data or information. But this school of thought in blockchain developers is that actually that is the biggest weakness. And that exactly happened with Equifax, HBO hack, Sony hack. What happened is that like Sony, HBO, all of them were hacked. Their data was not with themselves, but they had given it to some third party, trustworthy third party, and they themselves hacked or they purposely leaked or got hacked. So now in the context of software, we have to keep in mind, like the moment we say there is a third party, it is actually a weakness in your security. So remove them altogether if you want to build a really solid, secure system. And this is what I used to tell my friends. They like earlier 2 years back, some of them made fun of me. But then this is today's Toronto's map on the Bitcoin ATMs in Toronto. In some neighborhoods, there are more Bitcoin ATMs than bank ATMs. So even if you can be a naysayer, I can be a naysayer, all the banks, everyone can be a naysayer. But that's what the consumer wants. And all of us, at the end of the day, work in a way to keep our consumers happy. So this movement is actually from the consumer's point of view because they think trust is missing in every aspect, in public services, in banking, fake news, journalism, in every aspect. People nowadays think there is no trust remaining. So blockchain is gaining importance because it is bringing trust, and that is really important. And this is available on Block.to, and this is a very old map. In almost every hasty market, there is a Bitcoin ATM. And the purpose I'm saying Bitcoin ATM is nothing to do with the dollar price, but people want an alternative. That is what is more important here. So Nick is, sorry, I cannot really pronounce this last name, but Nick Szabo is the one who is the pioneer for smart contracts. He documented it, wrote white papers, and talked about it in 90s. So again, blockchain, we say it started from Bitcoin, but distributed system, decentralization, this was in R&D phase since a very long time. And so this is what he said, like there should be protocols with UI which are, and how to formalize secure relations over computer networks. And the beauty of blockchain, it is not just a technological solution. It is taking into aspect your legal aspect, regulatory aspect, the economics. All the world's leading economists, like the Davos Forum, there was only one word everyone was talking is blockchain. So economics is involved, there is even human psychology is involved. Everything is coming together in blockchain, and the most important is using cryptography. Cryptography is like public-private key encryption or different encryption algorithms on how these transactions are secured. So this is backed by strong cryptographic algorithms, and because of this, like any malicious interference by bad actors or unknowingly by middlemen is not possible. So what are the key? And again, I'm spending some more time on the history because what was documented as a research paper is exactly what smart contracts is today. And at that time, Nick Szabo exactly used the same word, smart contracts, and that is why in Ether the smallest unit is named after him. It's called as Szabo. What the key points of the early vision of smart contracts is that So we need smarter controls. In large organizations, people actually do not get along well with each other. What keeps them together working on a big project like a dam construction is the controls that that organization or the company has over its employees. So these controls are just not automated. Then there are, they often involve like, so trusted third parties, and you need, so why you need trusted third parties was mentioned and the problems with them. Then, yes, so this, without user interfaces, smart contracts are largely invisible. So it is both a blessing and a curse. To think about it, the contracts that are taking place, it's a code language, not everyone can understand the code, and it's mostly invisible. It's blessing because all of us now know that no one knows what is happening in the background. As opposed to some people having information about the smart contract, how it's working, and some do not having that information. Now like, it's better because of that, but then it's also cursed because if there is some serious flaw, then and it keeps on happening. Like you might be reading of wallets being hacked, and so these serious flaws are actually like a curse with smart contracts because many hacks are unintentional. It was a code mistake, which bug in the code, which millions of dollars was frozen very recently. And this was exactly written in 90s. That's the beauty of it. And again, obscurity is often critical to security. So in our traditional banking cells or any non-banking cells, we want the transactions as transparent as possible. I should know what is going on. But in the blockchain context, in smart contracts, it's actually as much as anonymity is better because that is more secure. Digital signature is not, so digital signatures is every participant in the blockchain, the way they sign smart contracts and interact with the smart contracts is through digital signatures. And these digital signatures are not exactly like a biometric because like my fingerprint can never be replicated by anyone else. Whereas in cryptography, like digital signature, if someone has my private key, they have access to my funds. So Nick Szabo gives the example of there is a wooden block which is used in some Asian countries as a signature. Each is personally carved. So that is their actual autograph. But that autograph is unique. But if someone else has that physical wooden block, then they are now owners of something. So that is what was, so digital signatures are used for interacting with smart contracts. And anything that is algorithmic in nature, the function of a third-party middleman, if it's algorithmic, if that can be programmed, then it can be easily automated in the smart contract. So now forget a banking financial system. Like literally any contract which can, where the interaction amongst the participants can be easily programmed, then you can have a smart contract solution for it. So now think about the potential applications. It's literally infinite and immense. So this is how today's world is. Every system has its own ledger, own format of ledger, and they have their own IP ecosystem. In the blockchain world, it is the same ledger which is every node or every participant is having, and even the ledger has the exact same format. So this is, and your smart contract now resides on each ledger. So the copy. So and I just want to make one point is they call it distributed ledger. It is actually replicated. So it's again a very incorrect terminology. So what are the smart contract capabilities? Is trustless. So when I say trustless execution does not mean it is removing trust altogether. Trustless means it is minimizing trust by distributing it to many participants. So let's say I have a secret and I want, or I have a treasure of $1 million and I want it to pass on to my children after my death. But the location of that treasure, I tell to all of you individually. but none of you know each other. So I'm just passing on that, and I trust each one of you individually, but not all of you together. And all of you are spread over the world. So that's how I am using it as a trustless model of telling all of you where my $1 million is. Like, I trust each one of you individually. You won't take it and you will pass it on to my children only on the event of my death. So this is what trustless means. And again, like, a lot of people, especially mainstream media, use these words like trustless in a very wrong way. Then these are self-executing contracts. So self-executing is, there is no manual intervention. They are autonomous in nature, they execute by themselves. Sometimes the entire end-to-end process is within the blockchain. Sometimes they get a data from, like, let's say from an IoT device or from a mobile device from outside the blockchain. Then there is something called as oracles which connect the blockchain with the blockchain world. But these are basically still self-executing contracts and they reside on the blockchain. The biggest difference I said is this. From non-smart contracts and smart contracts is they automatically enforce those obligations. So if someone has to be penalized or whatever the terms and conditions are of the blockchain, if that is not followed or fulfilled, then the penalty as mentioned is also enforced and ensure that that enforcement is properly done. So anything that is programmability of the interaction among the participants can be coded as part of your smart contract. This is important. Like, eventually now we are in a world where code is your law. That's it. The entire Bitcoin's monetary policy, people trust it because it is part of code. No one can change that piece of code. So at the end of the day, smart contracts, it is the law that is coded and part of your solution. It's not free to run. That is extremely important. You cannot misuse the system. For every smart contract transaction, you are spending real money. So in the blockchain context, we think of money as probably Canadian dollars, but in the blockchain context, it is the native digital token. So you are actually spending gas, which is the transaction fee, for executing each transaction. So it's not free. You cannot spam it is like an anti-spam filter. So when designing and writing smart contracts, you have to keep that in mind. Execution is autonomous to a certain degree. Execution is transparent. So when I say execution is transparent, is the activity that happens in the blockchain. You might not know identity, like the real person identity behind the addresses, but how the addresses and what is happening amongst the addresses, what value they are exchanging to each other, that is transparent. This is again important. People think of smart contracts only from the point of view of Ether or say Bitcoin and Neo, but actually smart contracts do not need a digital token at all. Fabric has chain code. Fabric is for permission ledger for enterprise applications, and they also use smart contracts. So it does not have any native token. And also people think like there cannot be smart contracts in Bitcoin. There it is also blockchain. There can be smart contracts in Bitcoin. The only difference is Ethereum is giving you a programming language which is like JavaScript and it's very easy to deploy applications, whereas the Bitcoin language is like assembly level language which really no one knows today. So this is like typically how smart contracts work in public blockchain. So like Ethereum, and again, think of it as any digital asset. Your home, your car, anything that can be tokenized rather than and digitized, you can exchange easily. Just like your Airbnb platform, you can have the seller and the buyer together, but the exchange happens on the blockchain, and the biggest advantage of blockchain is settlement and clearance is immediate. And that is why in the banking and financial industry, or where there are massive transactions happening, blockchain is the best solution. Still scalability needs to be addressed, but basically settlement and clearance is immediate. So if I send you Bitcoin from my mobile wallet, you get it immediately. There is confirmation. If I buy stocks on Toronto Stock Exchange, or like I have not done stock trading here, but in India, the clearance cycle is T+2. I think even in Canada it will be T+1 or T+2.
3 days.
3 days. It's T+3. So your actually the settlement clearance is really time consuming. In the blockchain world, it is like 15 seconds, 30 seconds. So that is again something what smart contracts help you achieve it. In the permission blockchain, so I don't want to dive deep into what is permission, what is public, but in permission blockchains, there are a lot of other participants also, and these participants are like regulators, and certification authorities. So conceptually, this part is somewhat similar, but then you have a regulator who will say, who will have more access. So different participants will have different levels of access, and you can define it. The certification authority will have, like even now, if you work in banks or critical products, you have like a lot of different products giving you certification authority. CA is one of them. So it's something very similar, but just that in permission and permissionless blockchain, the difference is anyone can access in permissionless. In permission, you can define the access at a at node level. So now let's see the different implementations of smart contracts. This is from complexity point of view. So the very basic one is I transfer someone a digital asset, you get it immediately. Then there is like, so then like say Netflix, but Netflix you buy, so online streaming, you just want to stream 30 minutes of a movie and you're paying for that. So that is relatively first level of complexity, where there is one like little conditions associated with it. Then there are like complex one where you are actually now buying your entire end-to-end. If anyone has taken a mortgage any part of the world, you know how many parties are involved and how much of paperwork is involved. So all of them tomorrow can potentially interact just with the blockchain system. But then there are so many different conditions. It takes data from credit, your credit score company like Equifax. So that is the current. So we have achieved till this point really well. This is what everyone is working on. So from this point of view, some of it is futuristic, but we still have the technology and proof of concepts have been done and achieved. So some of them will be self-paying cars. So if generally I have it in my slides, but because of time I have not included. But there is already a proof of concept where the car goes from a toll station and it pays the toll. The car pays the toll the moment the sensors detect at the toll plaza, and the transaction is complete. So there is no wait period. So these kind of autonomous behavior, we already have the technology. It's probably adoption might take some more time. And then there is this distributed autonomous government. So basically, you as a citizen will so all the public services like applying SIM card or what you can do online pay, those things, most of which are like contracts, those you can define it sitting at home itself, and like a lot of government internal processes are also completely autonomous in nature. And while I may think this is too futuristic, Canadian government is already bringing out this proof of concept where all the citizenship data will be on blockchain. It is with secure key. IBM is doing that, and you as a consumer, as a citizen, every citizen will have at least one bank account. So you as a citizen will decide which bank can access what data that I want to share. So generally all the financial institutions take all your data, but most of it they use for other purposes to promote other products to you. Not they really the product what you are applying for. So now you are in full control of the data that you are sharing with the banks. So it is not at all futuristic. In the next 6 months we will have that. And then this, I accept it's too futuristic. There is the called distributed autonomous society, like group of settlers from different are agreeing upon contracts. There is something called as liberal land near Croatia. They have taken one island and they want to make it a blockchain island. They might be smoking too much weed probably. These are just a few quick use cases. Digital identity, the one which I just mentioned, Canadian government is doing this with all the citizenship data. And again, that is like Equifax. If they are first of all doing in a permission ledger, which is okay, but if there is a code bug or there is some hack, then all the citizenship data is again exposed. So it's always a double-edged sword. There are risks associated with writing smart contracts, and so digital identity use case. This is so both these what is the current state and how the blockchain world will look like, and these are the benefits. Like so, there is more compliancy, there is more KYC, and all these protocols are better followed, and even the consumer is in full control of what that consumer or citizen wants to share with the outside world. Land registry is one of the most popular use cases in blockchain for public services. I want to mention land registry because now you can think of blockchain completely outside of the financial system. Your land title, which is on your name, all that documentation can be on the blockchain. So the PDF or the electronic copies of all the data is not really on blockchain, but the digital fingerprint associated with each document is on the blockchain, and any change in, even a slight change in that document will change the digital fingerprint. So that is how it gives a tamper-proof copy it keeps on the blockchain. So when all these news articles are, government of Georgia is putting all the land titles on blockchain, they are not putting all the soft copies actually, but like in future you may have like a legal chain, medical chain, like different blockchain for different use cases, where and if scalability issues are resolved, then it can have more data, but as of now it's just a really bad practice if your smart contract is putting lots of data on the blockchain. Then this is supply chain. Supply chain again completely nothing to do with financial system and supply chain provenance. These are the best use cases for blockchain because it is actually exploring all the capabilities that blockchain is bringing, and if you write smart contracts in very efficiently, then you have full auditability and tracking at a very micro level. So when I'm saying very micro level, recently Walmart did one, like they get pork from China, but it's like hundreds of villages in China from where this pork is coming, and if there is some recall, then it is almost impossible to track from where it originated. So Walmart just has to cut ties with entire China products, which is not profitable. Like it's of course not a good decision. So now with blockchain you can have that macro and micro level tracking as well, because of like the way blockchain by design, all the transactions you can link and find out from where it gives you basically full auditability. So what are the advantages of smart contract? So just by design of it, your smart contract is on-chain, it is replicated on different nodes, so there are backups. So the backup aspect is default being taken care of. We all have heard how Bitcoin, Ethereum are the world computers and the most secure and strong networks, and there have been hacking attempts. When they say Bitcoin have been hacked, it is actually the wallet and the exchanges which were storing the tokens, but not exactly the network. To hack the network, you need massive hash rate, electricity, which is not possible. So it's basically really safe and secure. There are no middlemen. This no middlemen is again more of an ideological thing as well, because in the blockchain world, in finance, you are your own bank. So if you have the private keys, you have full access to your fund. You decide what you decide how to use them, and most importantly, no one else should know how much funds you have. In the sense, even if right now that's the case, you can say, but all the bank employees, like not all, the bank employees who have access to your data, they can see all your credit card transactions, those are not encrypted. So some human person or even a system has full access to your records. Do you really want people to have access to your, not just financial, any records? So you are in full control of, you are in your own bank. Blockchain, like smart contracts, when done efficiently, save a lot of time, they avoid manual errors. This is really important because they reduce a lot of mental and computational transaction costs. So paperwork, sometimes the same menial repetitive work is kind of mental challenge, or like computational transactions is when you are remitting funds from here to say Philippines. There is immense amount of IT, like the end-to-end life cycle of that transaction. It goes through a lot of different IT systems, and it's just a lot of different transactions, and that's why the banks charge you $10. It's actually a cost for them as well. And so whatever are the benefits associated with blockchain, they are by default extended to smart contracts as well. Having said all that, there are definitely a lot of implementation challenges associated. One of them is your bug-free code. At the end of the day, the coding will be done by a developer. There is nothing like a bug-free system or software, and there have been a lot of different examples where the mistake of a developer, unintentional mistake, has costed millions. Again, if someone is from technical coding background, if there is like an infinite loop, then you will spend all your money on just one transaction. So you have to be really careful in that. Smart contract consume gas, that is real money. The biggest challenge right now, I'll say, quality skill set. And that is his point, is education. There is still no proper education in this field. And I'm not just talking about Toronto in general. And there is tremendous demand. Like they say, for every one blockchain developer role that is filled, 16 roles are open. But you do not have those 16 developers. So every company is actually hiring them and then giving them training. They themselves do not have trainers to train these developers. So that is, and this whole space is evolving. There are like evolving language tools. The infrastructure layer is, right now people are working on it, but is still kind of missing. That's why we have the scalability challenges. Any erroneous input from outside the system may cause issues in running blockchain system. And then there are legal and regulatory challenges, and I'm not saying taxation and those, but basically, like in Canada, there is a law that the physical servers have to be in Canada itself. In the blockchain world, that's not possible. Your data will be spread all across the world. There are other challenges like how to, some of the coins like Monero give full anonymity. How can?
Private blockchain.
No, so private blockchain is different, and that's why most enterprises are going. But if your node is outside of Canada, it's a private blockchain, it's still against current regulation. And even like some of them have for settlement and clearance, many countries have the regulation, the banks have to use SWIFT. They cannot use anything other than SWIFT. Then what is the use of if you have even a better solution, if the regulations don't support it? Then if something fails, then whom are you going to sue? So DAO is basically decentralized autonomous organization. It's basically an ecosystem like a coral reef. It has its own life, completely autonomous execution. But if that fails, whom to sue? Because it does not have any employees, no nothing. It's just a code running in the background. There are jurisdiction challenges. Some of the blockchain which are a little bit centralized, they have something called as a kill switch. So kill switch means few nodes can actually shut down the entire blockchain. If the data is encrypted and you know that the data was being used by terrorists, but still you cannot do anything. It just happened with Apple data, like mobiles were used by terrorists, but Apple said we are not going to help FBI in decrypting that. So it's the same challenge. And finally, I started it with Nick's 1998 paper where he mentioned about smart contracts. This is what he tweeted in 2017. It is still relevant. What he says is that all these successful internet companies are successful because they are basically trying to do contracts with each other. So you can take eBay, Google, Facebook, we all know they are actually just taking your data and selling to advertisers. So they are a place for the buyer and seller. eBay is for that. Amazon, you want something, you will get that. It's all of these are marketplaces. Uber, if you want a cab, the cab driver will be listed. All successful internet companies are using contracts as their primary integral part of the business model, and now this is what smart contracts is bringing. So with smart contracts now we do not even need Uber, we do not need Amazon. There's Open Bazaar, which is a competitor for Amazon. For every big company like Uber, there is Arcade City. It's in proof of concept, but there is already, we can now we do not even need these companies. And what smart contracts is bringing is this. You are having contracts between the regions which are differently lawed and cultured people. So what Nick says is your contract in one region may be death sentence in another region. It's not literally death sentence, but there are cultural differences in how contracts are designed. If you are implementing the same system in different places, but that's what actually smart contracts will help you achieve. And I still have some time, so I wanted to show you like an actual demo of how smart contracts work. And the best way to explain smart contracts, just give me time. So the best way to explain smart contracts is actually, has anyone seen this? I think I touched. Yeah, so this is Ether Delta. Like there are Coinbase, Quadriga CX, CoinSquare, a lot of different exchanges. Ether Delta is a decentralized exchange. So what is the point of all this decentralization if you're buying Bitcoin from a centralized place? So Ether Delta is a decentralized exchange. I will show you how to buy a token or an asset. I'm not even saying you buy that, but just as an example. And I myself am against all this dollar value and talk about that, but Ether Delta is the best implementation, live implementation, which is used by millions and the best smart contract solution out there, which any one of you can use. To start with, you do not need to create a login. All you need is to import your private key and public key. So the moment you say import account, you just have to put in your key, which is your public key is like your email address and your private key is like its password. So that is not stored on any other server, it is stored locally in your browser. So now, so this is the first level. So I've already added my, I've already imported my Ether account addresses, and if you see, I have like 0.009 Ether, which is less than 1 cent, probably $1 in my account. But then, if I have to transact with Ether Delta, I have to transfer from here to here. This is the smart contract between me and Ether Delta. So there are unique smart contracts in decentralized exchanges. So if you see, what it says is use this to withdraw from Ether Delta smart contract to your personal Ethereum wallet. So this is my personal Ethereum wallet, and this is the smart contract associated with my, so identity, I'll use the word identity. And if I want to, so the moment any ERC20 token, which is Ethereum based token, is deployed on the mainnet, all the holders of the token can start exchanging. You do not need to contact that exchange, please list my token. So this is a complete autonomous, they do not have any customer care, nothing. If there is any problem, you are responsible for it. The user interface is really bad, and that is also one of the biggest problems in blockchain today, because the developers are not really UI UX savvy, and most of the problems in blockchain are actually scalability. Of course, it will take time, but UI related.
Yes, already is complicated.
Yeah, no, it's complicated, but then so just. So if you want to buy any token, so just for an example, I'm adding Ucash token. So each smart contract is associated with a smart contract address. And the identifiers, so this is in public knowledge. So the smart contract address, all of us have the same address. There is a name, this may not be unique, and the number of decimals. So the moment I add that, yeah, I know it has. Okay, I should have just a moment. So I can add Ucash or literally any token. So it is now showing the order book of what, so these are the current buy orders, these are the current sell orders. Again, this is now something a little bit similar to your traditional exchange, but remember there are no middlemen, it's just me and an autonomous software that is working in the background. If I want to buy, I'll just click here buy. So someone is willing to sell like Ucash worth, so 596 Ucash for say 0.0041 Ether. All I need is gas. So this gas is actually what I need in my personal account, which is like the transaction fee. And if I click on buy, if it goes through, it will show. So it immediately created a transaction. It takes time. So if this goes through, the trade will, it's shown already as pending. Within 17 seconds, I have the tokens with me, and the whole thing is done using smart contracts. This is what is to be understood from this demo. If you think about it, like and this you can do for hundreds and thousands of tokens. So let's say if you want to list your token on any centralized exchange, you have to contact them. Most of them charge a heavy premium fee. Here you don't need, and even like any mistake from your point of, if you do a mistake, then there is no customer care. It's wild west of blockchain. That's the biggest problem also right now. So the moment I have it, I can now transfer from the Ucash I have to my personal wallet. So this quantity will be reflected here, and I just have to click on withdraw, and from transfer from my smart contract with Ether Delta to my personal account. Yeah.
Do you know if they have sorry, I'm trying to frame this question.
Yeah. Yeah, so my time is also up, and this is just the architecture. So all the settlement and clearance happens here on blockchain, fully decentralized. The entire end-to-end is not really centralized, not decentralized, because their order books are on their standard centralized database. But that doesn't affect you, because even if there's something wrong in their database, your tokens are with yourself. in your own, you are in full control of it. Well, that's it from my end, yeah.
Do you know if they have an API?
Yeah, I think they have.
It's been a long day, sorry.
No, I think they have.
They do?
Okay.
Want to take some questions?
Yeah. Yeah. Yeah, go ahead.
You mentioned a few use cases, so let's say land and government operations.
Yeah.
Is it all based on proof of work?
So if you are using Bitcoin blockchain, it is proof of work. If, like, depends on the blockchain you are using for notarization. So tomorrow, like within 1 year, Ethereum will be proof of stake. So if you are now doing it on Ethereum, it will be after 1 year, it will be proof of stake.
And how is proof of stake? Or is it?
So proof of stake is like whoever has say 10,000 Ether, they can stake. Like literally, it's like locked with the network. You cannot withdraw it, but in return you get every few weeks or on a set period you will get something like a savings account. Yeah.
So my beef in general with Bitcoin is the carbon footprint.
Yeah.
So is it the same case in case of Ethereum or?
As of now, yes, and that is one primary reason out of many others that it is going to proof of stake. Like, yeah. Anyone? Okay, I think it's his time. Sorry.
Don't want.
Okay.
Okay.